Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 11 and 12 Maths Euclidean Geometry, proof and application of the theorem which states that a line drawn perpendicular to a chord bisects the chord. The question that we're going to be looking at is from the November 2017 paper 2, and it reads as follows. It says, in the diagram below, O is the center of the circle and point T lies on the chord RS. Prove the theorem which states that if OT is perpendicular to RTS, then RT equals to TS. Now, this is a proof, and remember that for proofs, the first thing that we need to remember is the construction that we're going to be doing in the diagram. Secondly, we need to look at the reasons that's going to be used in that particular proof. Construction is going to be as follows. We're going to be joining radii OR and OS. That's our construction. Now, remember that radii are equal. The second thing that we are going to be looking at is the reasons that are going to be used in this particular proof. Remember that we're required to prove that RT equals to TS, which is this, RT equals to TS. In order for us to do that, we are going to be proving that two triangles are congruent. Remember that congruent triangles are identical. So the two triangles that we're going to be looking at is OTR and OTS. And if you look carefully, you'll be able to see that OR equals to OS radii, T1 equals to T2. That is because we are given that OT is perpendicular to RTS, and we have a common side here which is OT. And therefore, we would be able to show that the two triangles are congruent by the reason 90 degrees, hypotenuse, and side. Remember that for congruency, we can show one of four cases that two triangles are congruent. So let's go write that down. So we'll start off with the following. Construction. And our construction will be join radii OR and OS. Our proof would be as follows. Remember that we're going to show congruent triangles. So let's say in triangle OOTR and triangle OTS. Our first statement will be that OR equals to OS radii. OR equals to OS radii. My second statement will be that OT is common. So I'll just write down OT equals to OT, and I'll write down common. My third statement will be that T1 equals to T2 equals to 90 degrees. And that will be because I'm given that OT is perpendicular to RTS. Therefore, I can now conclude that triangle OTR is congruent to triangle OTS, and my reason will be 90 degrees, hypotenuse, and side. So in conclusion, if two triangles are congruent, it means that all their sides are equal and all their angles are equal. So that means that RT must equal to TS. Therefore, RT equals to TS because the two triangles are congruent. So we have congruent triangles. Learners, so that's how we do the proof for proving that if a line is drawn perpendicular to a chord, it bisects the chord. Once again, make sure that you learn the construction and the reasons that are used in this particular proof. Now let's go look at the application of this particular theorem. So it says in the diagram, O is the center of the circle ABD. F is a point on chord AB such that DOF is perpendicular to A. AB equals to FD equals to 8 centimeters and OF is equal to X centimeters. Now, remember that we just proved the theorem that if a line is drawn perpendicular to a chord, it bisects the chord. So let's look at our information. It says here that AB equals to FD equals to 8. So if AB is equal to 8 centimeters, remember we are given here that a line is drawn perpendicular to this chord, which makes AF equals to FB. So therefore that's going to be 4 centimeters, that's AF, and FB is also going to be 4 centimeters. What else are we given? We are given that OF is equal to X. See that AB equals to FD equals to 8. So FD is also equals to 8 centimeters. And if OF is equal to X, that makes OD 8 minus X centimeters. And what do we know about OD and OB? Well, they are radii. So therefore OB is going to be 8 minus X centimeters. And if you look very carefully, you'll be able to see that we now have a right angle triangle, which is OFB. We can now use the theorem of Pythagoras to set up an equation and solve for x here. So AB equals to 8 centimeters, and that was given to us. Therefore, what can we now say? Therefore, we can say AF equals to FB, AF equals to FB, and that's equal to 4 centimeters. And the reason here is that we have a line drawn perpendicular from center to chord. The next thing that we wrote was that, remember, AB equals to FD equals to 8 centimeters. Therefore, remember, OD is going to be 8 minus X centimeters. So let's write that down. FD is equal to 8 centimeters. That was given to us. Therefore, we can now write that OD is equal to 8 minus X centimeters. And then the next thing we wrote down was that OD equals to OB radii. OD equals to OB radii. Therefore, OB is now equals to 8 minus X centimeters. Now this all leads to the following. Triangle OFB. OF is X, OB is 8 minus X, and FB is equal to 4. So therefore we can now set up our equation. So we'll write down in triangle OFB. We're going to be using the theorem of Pythagoras here. We're going to say that OB squared is equal to OF squared plus FB squared. Pythagoras. Therefore, what's OB squared? Well, there's a here 8 minus X squared. OF. So OF is, we've already got it to be x, and that was given to us. Remember, OF is equal to x. That was given. So OF, that's x squared, and FB, FB is equal to 4 centimeters plus 4 squared. So therefore, we have an equation in terms of x, so now we can solve for x. So let's square this binomial. 8 squared is 64. Double the product of these two terms. So that will be 8 times minus x is minus 8x. Double it will be minus 16x. Minus x all squared plus x squared equals to x squared, and 4 squared is positive 16. So what do you notice? X squared on both sides of the equation cancel. So we are left with negative 16x. If you can bring it to the right hand side, it becomes positive 16x. 64 minus 16. So what do we get there? 64 minus 16 equals to 48. Therefore, if we divide both sides by 16, so we get 48 divided by 16, because we're solving for x. Therefore, x will equals to, let's divide that by 16, 3. So x is equal to 3 centimeters. Let's answer our question. It says determine the length of the radius of the circle. The radius of the circle is OD equals to 8 minus x centimeters. So OD equals to 8 minus x centimeters, which we've already written down. Therefore, 8 minus 3 is going to equals to 5 centimeters. And that's our solution. The radius OD is equal to 5 centimeters. Learners, if you haven't subscribed already, subscribe to JL Maths YouTube channel, like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.